All right, I'm going to try to run through this as fast as I can because I don't want to talk. I hate talking. I wish I could do American Sign Language to you guys, so I'll just shut up and start teaching. Vectors basically represent how we analyze things that move with a direction and a magnitude, or a direction and a distance or force. So basically, if we have this guy, or this monkey man, who can shoot a bow and arrow, right, there's your arrow. This arrow is going to leave with a distance and an angle with the horizon. This right here, this thing, is basically how we represent that initial velocity, that initial movement of the arrow. This is called a vector. Vectors all have an initial point, a terminal point. Don't forget, terminal just means end. A magnitude. Magnitude just means how long it is. We represent that by this. Oh, let me say this first. This means the vector u. Okay, so this symbol right here. In your book and in text and things like that, you will just see it as a really bold u. Okay, but I don't want to write that out every single time, so I just draw this little like half arrow above it that tells us that it is a vector. Okay, so back to this. This is the magnitude. It's kind of almost looks like a double absolute value. This stands for magnitude. And when you think of like magnitude, you think of maybe an earthquake or a volcano, the magnitude of the earthquake, and how much you shake. So the magnitude is just how big something is. So how big the vector is. Or the distance, or whatever. It's just the length of the vector. So I'll say that as well. Length. Yeah, define it in one word. Magnitude is length. This means vector. It has an initial. It has a terminal. So let's analyze some vectors. Sorry, I forgot that I need to talk about two more things. You don't know how to represent vectors in form. So component form is going to be the easier one to use. This is basically assuming that the vector starts at 0, 0 at the origin, right? You can make it look like a happy man or madman, however you want to see him. I kind of like him because he looks like a monkey man. Yeah, I like that guy. All right, anyways, so with this, if we start at 0, 0, we just go however far in the x direction, and then that's that part of the vector, and then however far in the y direction, and you get your actual vector. It's just like graphing points, but instead of just putting a point at x, y, I'm going to draw a line with an arrow going to x, y, because it is a vector. It is a direction and a distance. Standard form, basically the same thing. Notice that you have the x's and the x, the y and the y. They mean the same thing. X, basically, this is not too terribly important. I want you to have seen it at least once, though. All this is saying is x. If I were to multiply x in, it would only apply to the x's of the component form. If I were to take the y and multiply it through j, it would only apply to the y parts of the component form of the vector. So, x in front of I, y in front of j. Happy day. Banana. Here is one type of example that you will see. Find component form, standard form, and magnitude of the vector. Usually it's only going to ask you for one of the things, but they're all very similarly related, so I'm just going to do one example and kind of shorten the time of this video a little bit. So, to find the component form, if I know that this vector starts at -112, well, if I look on a grid, that's somewhere up there. It's -112. And it goes to 6, 6, so 6, 6 is over here somewhere, say. So this vector goes down like this. Well, the only parts that I care about of the vector are the x direction and the y direction. So if I find how far it moved in the x and how far it moved in the y, that is component form right there, x, y. So in the x direction, from -1 to 6, it went up 7. So there is the x part of your vector. From 12 to 6, it went down 6. So -6. There it is, component form. To change this into standard form, Just take your x, throw it in front of I, so 7I minus 6j. There's standard form. Whatever signs are in front of your component form vector, use those for this. Excuse me. Whoa! I ate the Snickers and I have a peanut stuck in my throat. Oh! Poor Mr. Pike. Things always go wrong for him on this day, Friday the 13th, 2013. Yeah. So here are our two forms, component and standard form. If you want to find the magnitude is basically the length of the vector. So if I just want to find the length of the vector, and I know that this is 7 and this is -6, then all I really need to do is just, oh man, it's raining pretty hard outside. Can you hear it? Maybe, I don't know, whatever. But all you need to do is just do the distance formula. So basically, 7 squared plus -6 squared, or x squared plus y squared. Take the square root of that, so this is 49 and 36. 49 and 36 is 85. So the square root of 85 is a magic trick, and that magic trick is going to tell me that 85 is 9.22. Well, there's your magnitude. Or if you really want to be exact, 9.219544457. Yeah. That's as far as I can go, because I'm not that smart. Alright. You may also see problems like this. Well, not may. You will also see problems like this. This is basically addition and subtraction, multiplication of vectors. You're going to do this just like you do any other number. So, oops, meant to have that on top of you. My bad. Put it in black so you think it was already there. Yeah, that was already there. That was a pretty good cover-up. I'm proud of that. So if I know that u is 2, 7, I can say 2 times the vector 2, 7 minus 3 times the vector -3, 14. And then these vector symbols basically are going to act like parentheses. So I'm going to go ahead and take this -3 and distribute it to both terms in here. So, and also with the 2, I'm going to distribute to both terms in here. So this will now be 4, 14. I'm going to go ahead and take the -3, all of it. So this will turn into plus 9, 14, 28, 42, so -42. And then I can just add them how I see. X is 2 x's, y is 2 y's. So x to x, so 4 and 9 will make 13, y to y. 14 and -42 will make -28, and there is my resultant vector. I'm going to do one more of these operation ones to kind of show you guys how it goes. So again, this time I have 3 vectors. I know vector w is 0, -1, so I'm going to substitute what it is, 0, -1, minus what u is, and u is 2, 7. And plus what v is, so -3, 14. And oops, that's not supposed to be there. 14, there we go. And what I like to do is I do not like subtracting with these things. So I'm going to go ahead and take this negative, distribute it to both of these, so that I have 0, -1, plus -2, -7, plus -3, 14. And then I can add all of the x's together. So by doing that, I will add 0, -2, and -3 will give me -5. That's the x part of your new vector. You have -1, -7, and 14. It's -8 and 14 will give us 6. There's your resultant vector. Next new concept that I'm going to talk about with you guys is unit vectors. Unit vectors are basically the vectors of magnitude of 1. So if I were to measure them, they are 1 unit long. This is basically coming straight from your unit circle. Every point on your unit circle that we used had a distance of 1 because the radius of the circle was 1. So no matter what vector that we find to be a unit vector, its magnitude should be 1 in the end. Basically, if we're given a vector and it says find the unit vector of this vector, then use this. You're going to take the vector and divide it by the magnitude. So let's look at one. So let's say we have to find the unit vector of 3, 7. So I'm going to take the vector, whatever vector that is, and divide it by its magnitude. Well, I know that the vector is 3, 7. To find the magnitude, I can take square root of 3 squared plus 7 squared. So this is 9 and 49 will make 58. And I'm going to divide this by square root of 58. So here's the nice thing about me, is I am pretty relaxed. So you can just say that this is 3 over root 58 and 7 over root 58. If you get to a multiple choice question on a test, make sure you can just punch in the calculator and check and make sure the numbers are the same, or be able to rationalize if you need to. Okay, but this is basically the unit vector. As long as you know how to do the pre-cal, I'm good. Another type of example that you're going to see is one like this. Give a vector with a magnitude of 5 in the same direction as 2, negative 3. So right now, this vector, if we just look at the magnitude of this, is 2 squared plus negative 3 squared. So this is the magnitude of 4 and 9, which is square root of 13, which is smaller than 5. So here's the thing. If I find the unit vector of this, the unit vector of that one has a magnitude of 1. So basically, if I go 2, positive 2, negative 3, that vector looks like something like that. That magnitude there is square root 13. However, if I find the unit vector, which has a magnitude of 1, I want one with a magnitude of 5. So all I need to do is take this unit vector, multiply it by 5, and I will have 3, 4, 5, a vector that is 5 times as long as my unit vector. So it will have a magnitude of 5. So just finding the unit vector, I already have the magnitude of it, so I can say that this is 2 over root 13 and negative 3 over root 13. Now to get this to be a magnitude of 5, just multiply by 5. So then our new vector is going to be 10 over square root 13 and negative 15 over root 13. Check it. I bet the magnitude of that thing will be 5. Like magic. Last concept that I'm going to talk about with you guys is the direction angle of a vector. So like I said, a vector has a direction and an angle. So we need to find the angle now. We found the direction, magnitude, the length, everything like that. Now we just need to find what kind of angles we're looking at. Don't forget, just like in chapter 4, we're going to measure from the positive x-axis to our side. Same over here, positive x-axis to our side. That is the angle that we are looking for. Not necessarily just the angle inside, though we can use that to help find our entire direction angle. So let's look at an example. Let's say we want to find the direction angle of negative 3, 4. So negative 3, 4, that is over negative 3 up 4, so it's somewhere up here. And I want to find the direction angle, which is all of that right there. Okay, so I know this went negative 3 up 4. Well, don't forget, straight across is 180 degrees. So if I can find this angle in here somehow, then I can do 180 minus that angle is what's left, which is your direction angle. So in doing that, I have the opposite side, I have the adjacent side, so I can say tangent of that angle is the opposite, which is 4 over negative 3, opposite over adjacent. You'll come out to be, your angle will be 5313. Now, if you punch in 4 over negative 3 in your calculator, this is going to give you a negative angle. Well, think about that. For tangent inverse, that's in the 4th quadrant, so usually we would go down from 0, so yeah, it would be negative. But obviously, just looking at our picture, we want that to be a positive angle so that we can do 180 minus it. Okay, so then in doing 180 minus that angle, you're going to come out with 126.87 degrees. And there will be your direction angle of your vector. Hopefully this video was helpful. Love you guys, and I will see you in class. Bye-bye.